So usually when you look at all the high throughput data sets that come out where people look at, say, which factor helps the cell make what kind of decisions, where do these factors bind on the genome, how do they work together, which factor talks to which other factor, it's a hairball that you get finally, which looks horrible. It's like so many proteins, and every new measurement you make is another mess added to the hairball. And from this mess, you want to extract the key machinery that's actually making the decision for you. And the question is, how do you pull out that piece from this jumbled mess that you have in front of you? And so what Matt Thompson, a graduate student in the lab, and I figured out was that by looking at how the shape of the hairball, so to speak, changes as the cell moves around and makes different choices, you could actually pick out very few factors that seem to move in significant ways which reflected what the cell was thinking of doing. So it's almost like you could just look at a few factors and read the mind of the cell, so to speak. And so just by looking at what cells made what decisions and how the hairball moved, depending on which decision the cell was making, we could certainly extract a handful of factors that were changing during this process of decision making. And these factors are already present in embryonic stem cells, and they were going up or decreasing in level as the cell made the choice. And then we could show that these changes were actually not just reflection of the choice, but actually an inherent machinery that controlled the choice. And it so happened that two of the factors that are key to this decision making are key factors that maintain pluripotency. So they're OCT4 and SOX2, which are known even for reprogramming. But these same factors that hold the cell stably in this pluripotent state also help it choose between two possible outcomes at the end of the first stage of differentiation, which is to give rise to mesenteroderm progenitors, which give rise to all the muscle and bone and gut in your body, or neurolectodermal progenitors, which give rise to the skin and neurons. So these two same factors that are holding the cell from and preventing it from differentiation also help it choose between the two. And I think the basic point was that instead of both of them preventing the cell from exiting this pluripotent state, one of them closes a door to one fate, the other closes the door to the other fate. And together they don't let you go anywhere, but you can open just one door or the other. And since these factors make up the doors, they can sort of decide which door to open and let the cell go through into the mesenterodermal fate or the neurolectodermal fate. So I think that's sort of what we discovered.